Well, hi, good morning. Thanks so much for joining me here in my shop. It's another fantastic day outside. Maybe not so much in here. So my intentions today are to change out 3 capacitors. And I'm probably not going to do the work on camera, but I'm going to show you my, what it is I'm doing just before I do it. So I've made a little diagram here. This diagram pictorially matches the layout of the parts right in here that I'm concerned about. And I've laid the 3 capacitors of concern here, plus I've noticed a replacement, a replacement, a replacement, and another replacement over here. Already done, plus this resistor was changed out. So I've included those just to double check their values and stuff like that. So I've made this sketch here, so I now know for sure by working with the information from the radio the values of these 3 capacitors, so I'm ready to change them. And I've also verified the size or value of these replacements. And these are all exactly correct. So whoever did the work here paid enough attention and had enough of a parts stock to put the proper parts in. But that person didn't go quite far enough in my mind. They really should have gone after this one because it's right there. It's easy to get at. Should have gone after this. These other ones, yeah, I think they're worth getting out, but I can see why he didn't do them. It's a hassle. And if the radio is working, why take on a hassle? But these are not going to be easy to do. Now, how did he do it? If you look at this capacitor and this one, you can see the leads are pushed down through the board and have been soldered underneath. This one, he's cut the leads short, and with this too, which is what I intend on doing, cut the leads short and then solder the parts in from the top. To do this, whoever did it had to release this board from the chassis. To release the board from the chassis, you've got 3 of these twisted tangs. These things are often one-time things. Twist them once into place, great. Twist them back straight, yeah, you might get away with that. Twist them back into place and they almost always will rip off at that point. So if we take a little bit of a closer look at those tangs, what do we see? Okay. Half ripped off. This one here also half ripped off. It's just 3 of them here. So, let me just take a closer look. I got the camera here. I might as well take a closer look at these different capacitors here. 100 picofarads. 100 picofarads on that capacitor. That's right. That matches the schematic. And then here's this one here. So I'm pretty sure the last guy to do this lifted the board off, did the work underneath. It's the only way he could have done this. Put the board back on, managed to twist those tangs enough to lock the board back down without ripping them off. So all indications are whoever did this work really knew what they were doing. Just didn't quite go as far as I might have on this. Or am I a fool to attempt this? I don't think so. I think these are fairly important capacitors too. So that's what I'm going to do. I'm going to nip these off, leave the wires sticking up, try to clean off the wires, try to hook up the new capacitor to the little wire tail sticking up through here. Avoid lifting this board because I think it's not going to come back. It's not going to be good. And I can probably get this guy out, and I might even be able to solder under here. Just fake my way in there. There'll be enough tail on here anyway, so it doesn't even matter. That's the plan. So I'm going to go after this one first. This is a 2 nanofarad or 2000 picofarad capacitor, and I've used all my 2000 picofarad capacitors that I had. So what I've done is I've combined a 1500 and a 500 here, and then on the meter you can see I'm checking it to make sure it's 2 nanofarads, which it is. So I put these two in parallel to replace this one. Okay, so I checked on the schematic. This capacitor that I've cut away now, I'm about to put this in, carries the signal to the electrostatic tweeter. So if the old capacitor, which I tossed aside here, was weak and not able to pass the signal properly, then that would weaken the tweeters, and it seemed to be that way. So let's stick this guy in here. I think I said something about not videoing this, but I say lots of things that turn out not to be true. Well, maybe not lots of things. Maybe just some things. Okay, that'll work out fine. Now, before I solder this, is there anything else in this area that needs to be soldered? No, I don't think so. All I'm going to do is solder that. Okay, I'm going to carry on. Hopefully off video, but you never know. Yeah, so much for off camera. So this is the capacitor I'm going after. Here's my replacement for it. It's actually physically a little bit bigger. So, you know, even if it rides up a little, it's going to ride up a little bit high because I have to, I can't push it right down on the board, I don't think. Just because I need to solder these leads and stuff like that. Deep breath now. If I can't do this, then I have to lift this board off and face all the problems that might come from that. Double check the size here. It's like 5,500 volts, 5,000 picofarad. And what did I write down for that? 0.005, which is this microfarad, which is the same thing as 5,000 picofarad. Very good. This guy goes in here. He's got to make contact. Now, some of that black compound stuff had come out and got on the lead wires here. Surely to goodness this little contact is available too. That little pin. Surely to goodness, but let's check it. Just a second while I throw stuff around my shop here. Okay, so we're going to check for continuity. Come on, little meter. He sings a song. There he goes. Okay, so we'll hear that if this is actually... How can this not be the same thing? Now you heard it. Hard to make contact. There we go. So I go right around those things, both of them. Now the other end. Or more importantly, I don't have to worry about shorting between these things. Let's get the compound off the wire here. I'm going to scratch it up a little bit. Don't cut it. I think it's okay now. Okay, let the cameras roll. Over. Okay, I'm just shaping the wires here a little bit. This is kind of why I wasn't going to put this on video. I'll do just this one. How about that? Just this one here. Maybe I'm not seeing it right. Okay, that's one side done. Now we'll get to the other. Light duty pliers just don't have the strength to bend a wire like that. There we go, number 2. And I did it on camera. Now is that other one good? Yeah. Good. Now, next one, push this guy over here out of the way. Push this guy over here. Oop, he doesn't want to go. He doesn't want to go out of the way. So how am I going to get at this? Kind of here. It's got to be the same way. I got to do the same stuff, just in tighter quarters. Okay, free it up at this end. I can black compound's just crumbling away. That cutters don't want to go in there. Watch this on the camera, I might get a better view of it. In fact, oh, don't cut it there. I almost cut it at the wrong place. Okay, so is this terminal the same as this one? Maybe there's a chance that I don't really have to use this piece of wire here. Rip this capacitor out of here. Now I'm going to try that. There's a chance the capacitor is just going to fall apart and come out, or I'm going to pull the wire out of the board. I don't want to do that. So I'm just using some leverage here. A little more wire. Got it. Volts, 100 picofarads. That is, hey, that's the second. This one here, 100 picofarads is correct. 100 picofarads. Okay, I'm going to find a 100 picofarad capacitor. Okay, I will do that. Okay, let's see if I can get this capacitor into place. So there's the one lead there, and the other one here. I've shaped the leads on the replacement capacitor to hook in like that. Now, I just have to kind of clamp that down. It's not going to work like that. My grip on the capacitor. That's not very good. Could probably get away with it though, just by soldering it up. A little better. Okay. Just have to let my soldering iron heat up again. There we are. it on a bit of a bad angle here. If I bend that over, it's going to pull that wire. Ooh. Okay, I think it's okay. Ooh, didn't feel best. Still okay. Ooh, that other wire feels like it's weakening. It's going to break or something. I don't know. If it breaks off at the surface of the board, I'm in a bit of trouble. Don't break, baby. Just hang on. We're almost done. I feel like I'm talking to one of my cats. Get about the same response from the radio as I get from my cats, though. Well, I think I can get that tacked in there with some solder. Shouldn't fiddle with it more, or I'm going to get myself in big trouble. Big trouble. Wait, don't run. This kind of trouble is lots of fun. So I can't really see what I'm doing here. I'm sure you got a great view on the camera though. Okay, I think I got it there. A thin. I got it. That's it. That'd be it. Now, the last one. The last one is jammed up in here. It's about the width of my finger here. There it is. There he is. I think yesterday I said that this, or in the last video I mentioned this capacitor had penciled writing on the front and it was 0.1. It's the other way around. It's 1.0. That was nice enough. Can you see that on camera? Barely. It's nice enough to indicate whether it's which way it was up. I didn't pay attention. Let's take this end off first. Let's read what the real rating is on this. The real rating is 5,000 picofarads. What's that 1.0 for? Picofarads. That would be 0.1. Why am I? Oh! Look. You look at it this way. Look at this. This is funny. This is your funny thing for the day. Let me get this a little better here. So you look at it this way, you see 1.0 penciled there with a line underneath it. But if you turn it this way, you now see 0.1 with a line underneath it. And in fact, I read it this way. How did I read it? I don't know how I read it. I read it somehow, but it doesn't matter because in fact it's nothing. It has nothing to do with anything. 5.005 microfarads. 0.005. Now how does that compare here to my little diagram? The one we just took out is this one here. 0.005. It all adds up. Okay, let me fetch up a 0.00. Yeah, it's another 0.005. Okay, there we are. 0.005. It's going to go right in here. Oh, it's easy to get it onto the wrong little terminals there. Yeah, I think I'd raise the question, can I connect this capacitor to the terminal of this and make it easy? And the answer is no, don't do that. That's the answer. When I looked at the schematic, it was pretty clear. They have nothing to do with each other. Yikes. So what I'm trying to do here is just get the cutter onto the little tail of wire and scrape it with the cutter blades. I don't know how well I can do this. It's just so, there we are. Without cutting it. Scrape without cutting. Fortunately, there's a fair bit of black compound. It just shatters off here pretty easily. None of these wires have shown a resistance to being soldered so far. I've all been pretty happy about it. So I don't think I'm going to have a problem here. I'm getting anywhere doing this. Just a little bit of scraping's good though. Okay, this guy goes in. And the leads like this. Estimate the excess. Leave a little extra in case I did a bad estimate. Okay, there's the challenge. Get the capacitor in there. Okay, I'm taking a measurement where the loop needs to be bent. So I'm just going to bend the wire into a little hooky loop. Good. Okay, I'll solder that side there. Ooh, it's just the wire itself is very flexible. Oh no, I think I buried the other terminal underneath the new capacitor. Right on the edge of the capacitor. A bit of trouble here because I can't fiddle with the capacitor too much for fear of breaking the other wire off. I need to kind of flatten that wire down there. How am I going to do that? There we are. How's that look? Capacitor back a bit. Maybe if I grip it here. There we go. We're getting pretty close now. Down and around. Did the down, I don't know about the around. It's pretty good. Again, just tacking this is going to be good enough, I'm pretty sure. Good. That's good. Solder that in there. It's a good thing I didn't put all this on video. Doesn't look as good on the video, but looks great to my eye, so I'm going with that. I think that's pretty good. Oops. Good. Okay. Hey, you know what? That's 4 capacitors done. Was there another one? There wasn't another one. Well, that was what I wanted to do. Get rid of those crummy, bummy capacitors. Double check the other replacements, and make sure everything is honky dory, which it seems to be now. Dory. So, where are we on the clock here? I have time to give them a test. Yeah, why don't we do that? Okay, I've consulted with the moose. The moose says, yeah, you're ready. You're ready to go ahead and start this guy up and see volume down. We're in broadcast mode. speaker connected, the tweeters not connected here. I'll connect them on and off so we can hear if that capacitor made a difference, that we can hear. That'd be great. And I got an FM antenna hooked up. AM will rely on this antenna again, which doesn't seem to work so well, but maybe alignment will help all that. I think we're all set here. I've got the push button set to orchestra, which I now realize means no tone cut, straight through, no tone control. Which is kind of what I want. Good. Here we go. Now, of course, I'm going to engage the. I'm going to engage my dim lights here for this because I've done enough changes. And where we go? Here we go. Power on. Okay, the light came on. Good, good. A little bit of volume here. Okay, tubes are starting up. Let's go full power. Seem to have more volume, but I'm not sure. So there should be a station right, an AM station right here, but and you hear when I get off on the edge here of the noise. You hear how stuttery that is? I don't know, it's a bit of a strange sound to it. What I imagine is happening is something is limiting or clipping the signal, and those noise peaks are popping through that limit. I don't know. Who knows? Good and strong volume though, and everything. Just seems like it's just not receiving. FM now. Dirt on the volume control.
Just like also mentioning because I chart up values, which obviously did not become a bill, but it was a potential bill of law. Examples where public sector could have said a strong example of what inclusivity looks like, and like a very, you know, like what also like positive discrimination might look like, but it was the total
Trouble
opposite.
test.
And had it passed, it would have been not only within the public sector, but it would have been whenever the private sector is also dealing with the public sector. So it's setting, and we know that one of the biggest employers right now is the public sector.
Slight change, very similar to how it was.
So if the public sector
I'll leave it disconnected. Let's get some music on here.
To hire based on
Wow. Wow. It's really come up. The distortion in there suggests alignment is needed.
Why do you think
Weak station. Okay, that's enough of that. I really think now we're ready to align this radio. It seems to be strong. It's receiving quite well, at least on the FM. On the AM side, I'm going to guess it's just an alignment issue, and this thing's going to be working really, really well. So thanks a lot for watching that, and I'll catch you on the next video.